clustering using correlation, preserving indexing and K-means. This is a main project done by B. Dheeraj Kumar, N. Manisharan Rao, M. Shivakumar and Anup Chaudhary under the guidance of V. Soumya, Associate Professor at GRIT. List of content: abstract, introduction, scope, purpose, existing system, disadvantages, proposed system, advantages, requirements, modules, algorithms, architecture, UML, data flow diagrams, DFDs, screenshots and conclusion. Abstract. This project represents a new spectral clustering method called correlation preserving indexing, which is performed in the correlation similarity measure space. In this framework, the documents are projected into a low-dimensional semantic space in which the correlations between the documents in the local patches are maximized, and while the correlations between the documents outside these patches are minimized simultaneously. The proposed CPI method can effectively discover the intrinsic structures embedded in high-dimensional document space. The effectiveness of a new method is demonstrated by extensive experiments conducted on various datasets by comparison with existing document clustering methods. The existing document clustering methods are LSI, MI, K-means, etc. etc. Introduction. Document clustering aims to automatically group related documents into clusters. It is one of the most important tasks in machine learning and artificial intelligence and has received much attention in these recent years. The K-means method is one of the methods that use the Euclidean distance, which minimizes the sum of the squared Euclidean distance between the data points and their corresponding cluster centers. Latent semantic indexing (LSI) is one of the effective spectral clustering methods aimed at finding the best subspace approximation to the original document subspace by minimizing the global reconstruction error Euclidean distance. Scope. That correlation as a similarity measure can capture the intrinsic structure embedded in high-dimensional data, especially when the input data is sparse. Purpose. Online document clustering aims to group documents into clusters which belongs unsupervised learning. However, it can be transformed into semi-supervised learning by using the following side information. 1. If two documents are close to each other in the original document space, then they tend to be grouped into the same cluster. If two documents are far away from each other in the original document space, then they tend to be grouped into different clusters. Existing system. A typical and widely used distance measure is the Euclidean distance. The K-means method is one of the methods that use the Euclidean distance, which minimizes the sum of the squared Euclidean distance between the data points and their corresponding cluster centers. Since the document space is always of high dimensionality, it is preferable to find a low dimensional representation of the documents to reduce computation complexity. The Euclidean distance is a dissimilarity measure which describes the dissimilarities rather than similarities between the documents. Thus, it is not able to effectively capture the nonlinear manifold structure embedded in the similarities between them. The disadvantages of the system are: parameter selection is a crucial issue in most learning problems. In some situations, the learning performance may drastically vary with different choices of parameters. Proposed system. We propose a new document clustering method based on correlation preserving indexing, which explicitly considers the manifold structure embedded in the similarities between the documents. It aims to find an optimal semantic subspace by simultaneously maximizing the correlations between the documents in the local patches and minimizing the correlations between the documents outside these patches. Advantages of this system. A new document clustering method based on correlation preserving indexing, which explicitly considers the manifold structure embedded in the similarities between the documents. Modules we used in this project: pre-processing, documentation clustering based on correlation preserving indexing, K-means on document sets, classification of documents into clusters. The various pre-processing steps we've done. A new document clustering method based on correlation preserving indexing, which explicitly considers the manifold structure embedded in the similarities between the documents. The similarity measure based CPI method focuses on detecting the intrinsic structure between the nearby documents rather than on detecting the intrinsic structure between the widely separated documents. Documentation clustering based on correlation preserving indexing. In high dimensional document space, the semantic structure is usually implicit. It is desirable to find a low dimensional semantic subspace in which the semantic structure can become clear. Discovering the intrinsic structure of the document space is often a primary concern of document clustering. Since the manifold structure is often embedded in the similarities between the documents, correlation as a similarity measure is suitable for capturing the manifold structure embedded in a high-dimensional document space. K-means on document sets. The K-means method is one of the methods that use Euclidean distance, which minimizes the sum of the squared Euclidean distance between the data points and their corresponding cluster centers. Since the document space is always of high dimensionality, it is preferable to find a low dimensional representation of documents to reduce computational complexity. Classification of documents into clusters. How we do it? Online document clustering aims to group documents into clusters which belongs unsupervised learning. However, it can be transformed into semi-supervised learning by using the following side information. 1. If two documents are close to each other in the original document space, they tend to be grouped in the same cluster. 2. If two documents are far away from each other in the original document space, they tend to be grouped into different clusters. Algorithm used by the K-means. Decide on a value for K, the number of clusters. Initialize the K cluster centers. Decide the class memberships of the N objects by assigning them to the nearest cluster center. Re-estimate the K cluster centers by assuming the memberships found above are correct. Repeat 3 and 4 until none of the N objects change membership in the last iteration. System requirements. Software requirements. Operating system Windows XP, Linux. Language Java 1.4 or more. Technology Swing and AWT. IDE NetBeans 68. Now hardware requirements. System Pentium 2.4 GHz. Hard disk 40 GB. Floppy drive 1.44 MB. Monitor 15 VGA color. Mouse Logitech. RAM 5 MB RAM. Unified modeling language. We use this language in this main project so that it is user friendly and proves a user interface to this project. Various diagrams were used in this main project and those diagrams are discussed below. Use case diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, component diagram, deployment diagram, and DF. The use case diagram is as shown, where the user has many use cases with this main project and is given select the document sets, perform the clustering among the files, check the document info, etc. etc. All he can do with this. Now the sequence diagram from where we start to where we done the clusters. So it is all in a sequence and the sequence diagram is as shown below. The collaboration diagram is given. The state chart diagram where it starts with the state and ends with the clustering of documents. Select the different document, perform the clustering among the files, check the document info and cluster info, calculate the correlation measure, check the accuracy, clustering with cluster-wise dynamic generation, comparisons with cluster algorithm strategy, show the value, CPI and K-means value. Activity diagram is as shown. Component diagrams, various components are placed. Deployment diagram. Various screenshots were taken for the results of the main project. And this is the file we are going to use as an input, and this file has gone under stemming and it is removed stop words and etc. All the pre-processing steps are done and this file is reduced to the size 29.2 KB and we are going to use this file as an input to our main. Using CPI method, we have formed the various clusters and these files are ordered in the various clusters and the document info are given. And the cluster info using CPA method is given, how various clusters are formed. The correlation measure between the files is given, and the clusters formed using CPA methods. What are the clusters formed? They are given here, and we use now k-means for clustering methods, and the various clusters formed by k-means are given here. So the final result is here. Now the number of documents used for our main project was 28 and number of clusters formed was 11. The accuracy for k-means was given by 39.2857 and the accuracy using CPA method was given 85.714. And the normalized MI for these 28 documents and the number of clusters formed are 11, and MI value for k-means is 12.04, but CPA is 45.112. The various clusters are given below, and we got our conclusions from this comparison that we present a new document clustering method based on correlation preserving indexing. It simultaneously maximizes the correlation between the documents in the local patches and minimizes the correlation between the documents outside these patches. Consequently, a low-dimensional semantic subspace is derived where the documents corresponding to the same semantics are close to each other. Extensive experiments on NG20 routers and OH-SUMAD Corpora showed that the proposed CPA method outperforms other classical clustering methods. The CPA method has a good generalization capability and thus it can effectively deal with data with very large size. Thank you.